Hello. So in the previous couple of videos, we looked at sketching the graphs 1 over x, y equals 1 over x, and also y equals 1 over x squared. So we looked at sketching graphs like that, where you had like a constant in the numerator. In this video, we're going to look at 3 examples of sketching reciprocal graphs of linear functions. So basically graphs like this, or graphs in the form, I'll write this in red here, graphs in the form a over bx plus c. Essentially, we're going to look at sketching graphs like that. And I mean, with this third example down here, we've got this extra constant at the end there. So maybe you've got an extra constant as well there to deal with. So we're going to be sketching graphs in this form here and looking how you would do this. And we've got 3 examples here which we're going to go through. But before we do that, let's just remind ourselves on what these kind of reciprocal graphs actually look like. So when you've got y equals 1 over x, and I've emphasized here the positive sign, I've really emphasized that this is the shape you get. So you get in the first quadrant, you get this like curved shape here, and then you get nothing in the second, the fourth quadrants, but in the third quadrant, you get this curved shape again here. Now, when you've got a negative coefficient of x of the x, when there's a negative sign, so in other words, negative coefficient, so negative number in front of the x, basically, so negative coefficient of x. This time you get the reflected flipped over shape. So this time the graph is flipped over, and I'll make a note here that this is a positive coefficient of x there. Positive coefficient of x. Okay, so that's our shape. So we're going to bear this in mind. So let's start with example number 1 then. So we want to sketch the graph y equals 2 over x minus 1. Okay, so let's think about this. So our coefficient of x here is actually a positive number. Let's just emphasize this, that this is a positive number. So the shape of the graph is going to be this kind of shape. It's going to be a shape like this, rather than this this upside down shape here. It's going to be this shape here. So let's just bear that in mind, or let's just make a note of it, that the shape is going to look something like that. I'm just going to move this to the corner over there. So that's our rough shape. Now, how are we going to actually accurately sketch this graph? Well, we need to know the asymptotes. I mean, as I mentioned here, the asymptotes for the 1 over x graph are at x equals 0 and y equals 0. And that's because when you substitute in x equals 0 into these, you get 1 over 0, and that's undefined. But when you make x subject to the formula, you get x equals 1 over y. When you substitute in y equals 0, then x is undefined too. So that's how we work out our 2 asymptotes. And it's the same kind of process here. So first of all, we need to find the asymptotes. So find asymptotes. So to find the asymptotes, then again, we've got to make sure that if the function is going to be undefined, then it means that this denominator must be equal to 0. So we have one asymptote when x minus 1 equals 0. So in other words, when x equals 1. So when x equals 1, we have an asymptote. So that's our first asymptote. And then our second one, that's going to be, well, I mean, if we rearrange this and make x minus 1 the subject to the formula, so we get x minus 1 equals 2 over y. Well, we see that if y equals 0, then this is going to be undefined. So y equals 0 is also another asymptote. So we've got our 2 asymptotes, and that's now going to help us sketch the graph, because we know where the discontinuities are going to be in the graph. So when we sketch the graph, we've got an asymptote x equals 1. Let's just say that 1 is here. So we're going to have a dotted line there, which is going to be our asymptote. So the graph will not cross through this point. And also we've got 1 at y equals 0, so we've got 1 on the x-axis. So that's our next asymptote. And we know the shape is going to be this positive reciprocal shape up here that we mentioned. So it must be a shape like this. So it's going to be a shape like that. It will cross through the y-axis this time. And that's because we don't have an asymptote at x equals 0. We have an asymptote at x equals 1 instead. So we'll certainly cross through there. And in fact, when x equals 0, y will be minus 2, because actually when you substitute in x equals 0, substitute x equals 0, you get y equals 2 over 0 minus 1, which is minus 2. So this can be minus 2 down there, actually. We can just put that in there and label that in. So that will be our graph. So a rough shape like that. When you substitute 2 into this this function, you'll get 2 over 2 take away 1, which is 2 over 1, which is 2. So actually this coordinate up there would be 2 as well, but we don't really need to worry about putting that in, to be honest, but we can do if we want to. Okay, so that's the first graph done. How about our second graph? So again, the same process really. We've got to work out which shape it's going to look like. Now, the key thing with this one is we've actually got a negative coefficient of x there. So, I mean, you could actually rewrite this as, you could actually factor out the minus sign from the bottom. So that would become x minus 2 on the bottom with your 3 on the top there. So in other words, minus 3 over x minus 2. So that's actually the graph we, in theory, are sketching. So this time the shape for this one, let me just write a bit neater. So the shape for this one is going to be the reverse shape. So it's actually going to be this shape instead, because we have that negative, going back to this slide here, that negative coefficient. So it's going to be the flipped upside down shape instead, this one. Okay, so now we need to work out our asymptotes. So asymptotes. So where will our asymptotes be then? So again, we want if we want an asymptote, then we need this to be undefined, this function. So therefore, we need for our first one 2 minus x to be equal to 0. So in other words, we need x equals 2 to be an asymptote. So that will be an asymptote. Now, how about our second one? So again, when we rearrange this, we get 2 minus x equal to 3 over y. Now, when y is equal to 0, we get, again, an undefined error there. So that means that y must be equal to 0, and that's our next asymptote. So now we know the asymptotes. So now we can sketch the graph. So if we just do this, so our graph, again, our y-axis there, x-axis there, we've got an asymptote x equals 2, so 2 is there. So drawing our dotted line. We've got an asymptote again at y equals 0, so drawing a dotted line like that. And then we've got a shape like that. So yeah, the graph is going to look something like this. It's going to asymptotically approach x equals 2. And also from the positive end as well, it's going to do this kind of shape here. So that would be our sketch of y equals 3 over 2 minus x. And again, you can work out this y-intercept there if you want to. So when x equals 0, plug in x equals 0 into there, you'll get 3 over 2. So this is 3 over 2 over there. So you can write that in if you wanted to there, just to show you know that the y-intercept will be 3 over 2. Okay, great. So that's that one. Now, how about this one? So we've got 3 take away this reciprocal function there. If we just think about the reciprocal one first, we've got negative 1 over x plus 1. Okay, so let's think about this. So this time we've got a negative sign there, which means it's going to be, again, let's just make a note of the shape of this one. So the shape must be the negative reciprocal shape. So it must be this kind of shape. So we know that's going to be our rough shape. Now, if we just focus on the y equals, I'll do this in green. So we just focus on the y equals negative 1 over x plus 1 graph. What will our asymptotes be? Well, we've got an asymptote. We've certainly got one when x plus 1 equals 0, because obviously when the denominator equals 0, we get an undefined result. So basically, we definitely have one x equals minus 1. Now, how about the second one? So again, when we rearrange this, we get x plus 1 equals minus 1 over y. So that would imply that y equals 0 is an asymptote, specifically for this graph here. So I'll just put this in square brackets just to make clear that this is a bit of scratch work, a bit of rough work. So yeah, we know that this graph is going to have asymptotes there and this shape there. Now, with our graph that we want to sketch, we're adding 3 to it. So basically, I mean, if we think about the graph in the square brackets here, we've got the asymptote x equals minus 1. We've also got 1 going at y equals 0 as well, so on our x-axis again. So we know that, again, the shape is like this because it's a negative sign, it's a negative coefficient of x. So it's going to be this shape, and that's what the graph's roughly going to look like. But with our question, we're adding 3 to it. So we're adding 3 to the y coordinates. So we're shifting the graph upwards by a vector of, by a translation of 3, essentially, to a vector of 0, 3, if you'd like to think about it like that. So our graph, y equals 3 minus 1 over x plus 1. So that graph is just going to be the same one here, but shifted up by 3 units. So our graph, I'll just try and put everything in the same page here. So our graph is going to look something like this. You've got your y-axis there, your x-axis there. You've got your -1 here. And that's still our asymptote because we're not changing the x coordinates with this transformation. We're just shifting it upwards. So, okay, so if we shift this graph upwards, we're going to get a new asymptote at y equals 3 this time, because we're shifting this asymptote, this y equals 0 asymptote, upwards by 3. So we're going to get a new asymptote here at y equals 3 instead. Okay, so we got those asymptotes in there. Now, what can we do from here? We just sketch in the shape that we have. So it's this shape again, because we've determined that it's going to be a shape like that, and it's going to look something like that. Perfect. Yeah, so that'll be our sketch of the graph. Again, it's going to cross through the y-axis. So where is our y-intercept? So I mean, if we just sub in x equals 0, we get y equals 3 minus 1 over 0 plus 1, which is just 1. So 3 take away 1, which is 2. So this would be 2 up there, actually. So this would be our y-intercept 2. And so, yeah, this will be the sketch of the graph. So, yeah, so we've looked at 3 examples of sketching these reciprocal graphs. So these reciprocal of linear function graphs. So we're taking the reciprocal of a linear function. And the strategy is always the same. You want to identify your shape. Is it a positive reciprocal shape? Is it a negative reciprocal shape? And then you want to identify your asymptotes, sketch those straight lines in, and then draw your shape in a rough sketch onto your axes.